Okay, hello again. These are the questions and answers on metals. Hopefully you've tried them, right? Okay, let's take a look at the first question. Like other metals, iron is malleable and is a good conductor of electricity. Explain why iron is malleable. Again, why is a metal, any metal, malleable? Because layers of positive ions can slide over each other when heated or hammered. Explain why iron is a good conductor of electricity. We said metals in general are good conductors of electricity because it has free moving electrons, okay, which we call delocalized electrons that are free to move. So you have one mark for the fact that they are electrons and another one for the fact that they are free to move. The other question was, the student wanted to find out how easily different metal carbonates decomposed on heating. She placed a sample of a metal carbonate into a test tube and heated it, passing the gas given off through lime water. Of course, if you heat a metal carbonate, it gives carbon dioxide gas. How do you test for carbon dioxide gas? It turns lime water milky. She heated 3 other metal carbonates in turn and measured the time taken for the lime water to turn milky. So what she's doing is, if the reaction is very fast, then it will give a lot of carbon dioxide and the lime water will turn milky in less time. So that's what we're doing. If the lime water takes a long time to turn milky, that means the metal carbonate is not decomposing quickly. If it does not give any milky color after a long time, that means what? That means that the compound is not reacting at all. It did not decompose. Remember that breakdown of a substance to form products, this is decomposition. State the name of the gas that causes lime water to turn milky. Of course, we said when we heat carbonates, it gives carbon dioxide gas. Use the results to identify with a reason which metal carbonate decomposed most easily. So you look at the table again. This is the table again. Which one decomposed most easily? Most easily means it decomposed to give lots of carbon dioxide very quickly. That means the lime water turned milky very quickly. That means it needed less time. So which one needed less time? Copper carbonate. What do the results suggest about the effect of heat on sodium carbonate? It says sodium carbonate did not turn the lime water milky at all. That means, the first question says use the results to identify with a reason. Copper carbonate takes less time for lime water to become milky. Okay, what do the results suggest about the effect of heat on sodium carbonate? That the sodium carbonate does not decompose on heating. State 2 things that the student must do to make sure the experiment is valid. What is she doing? She is comparing different metals. But what you should have constant in this experiment is what? I should have the same mass of carbonate every time if I'm going to compare them, and the same volume of lime water, so that it will the time taken will depend on the reactivity of the metals alone. Okay, water is needed for iron to rust. State 1 other substance needed for iron to rust. We said iron needs water and oxygen. When iron rusts, a brown compound forms. It can be represented by this formula. What is the name of this compound? Remember we said this is iron 3 oxide. Equal masses of iron, magnesium, and zinc were placed in separate beakers, each containing 50 cm³ of copper sulfate. So you put the metal in copper sulfate. The mass of copper displaced in each case was found, and each experiment was performed 3 times. The results obtained are given. First of all, practical question. How can you tell that one of the results has been recorded to a greater precision? What do we mean by precision? Precision basically means accuracy, but it means which of these was recorded at a greater precision. If I give you a number in 1 decimal place and another number with 2 decimal places, which one had a greater precision? The one that had 2 decimal places. So when he writes in zinc experiment 3 that he got 1.10, that is a greater precision. So it has 2 decimal places instead of 1. All of them have only 1 decimal place, but only one of the readings has 2 decimal places. Write a chemical equation for the reaction taking place between magnesium and copper sulfate. Again, I'm going to remind you, chemical equation means simple and balanced. So magnesium Mg plus copper sulfate to give magnesium sulfate plus copper. State in terms of electrons what happens when a copper ion becomes a copper atom. Copper ions are positive, so they need to gain 2 electrons. What name is given to the type of change occurring? So when we gain electrons, this is called what? Reduction. State 2 observations you would expect to make when magnesium is added to copper sulfate. Again, if you add magnesium to copper sulfate, magnesium is more reactive than copper, so it will displace it. What happens? Again, what was the color of copper sulfate solution? The solution changes color from blue to colorless. And then magnesium plus copper sulfate will form copper. So that is a reddish-brown precipitate. Margaret goes on a holiday to the seaside. She notices some iron railings on the beach that are often in contact with the seawater. They are very rusty. The iron railings in front of her hotel, some distance from the sea, are much less rusty. Margaret predicts that seawater makes iron rust faster than rainwater. Describe an experiment that Margaret could carry out to test her prediction. So she wants to determine whether seawater makes the iron faster than rainwater. So how can she set up the experiment? First of all, how would she know if something has rusted more than something? We weigh it. If the nail rusts, that means instead of iron it becomes iron oxide, its mass should increase. So in order to know which one has rusted, I need to weigh the nails first. So I weigh the nails using balance. And then I put them into separate test tubes. And then I need to put equal volumes of seawater and rainwater. So you can specify or just say equal volumes. And then you need to leave it for the same amount of time at the same temperature. So you specify, leave it for 5 days at room temperature. After that, I want to know which nail has rusted. What should I do? Remove the nail. I cannot weigh it with all the water in it. I need to dry it first. So usually we put it into beakers, separate beakers, and dry them in an oven. And reweigh. Now, how do I know which one has rusted faster? The one that has more increase in mass has rusted faster. Why is rusting described as an oxidation reaction? Remember that we said when something rusts, it loses electrons. So when iron rusts, it becomes iron 2+. So it has lost electrons, so that is called oxidation. Or you could say gain of oxygen if you want. Iron is a useful metal. One problem with using iron is that it can rust. Name the iron compound present in rust. We said when iron rusts, it forms iron 3 oxide. Please note here he's asking for the name. There was a previous question that was asking for the formula, but this one is asking for the name. The name is iron 3 oxide. Name 2 substances that iron reacts with. When it rusts, remember we said iron needs oxygen and water. What type of reaction occurs in the rusting of iron? We said when something rusts, the iron changes to iron oxide. It gains oxygen or loses electrons, so that is called oxidation. Okay, galvanizing can prevent iron from rusting. In this process, iron is coated with another metal. Remember we said galvanizing is coating iron with what? With zinc. Identify one object suitable for galvanizing. So if I'm trying to make one of these, which one will I do galvanizing for? Remember that galvanizing is more expensive. It's not an easy thing. So I need to do it for something that is important. It's not a machine. So if I say bicycle chain, do you know what's a bicycle chain? Bicycle chain is the chain on the bicycle. This is something that has friction between metals. Usually the bicycle chain would be, if I want to prevent it from rusting, I would use oil or grease. The bucket is something that I can do galvanizing for. The car engine, we said an engine or a machine will need oiling. What about a drink can? Something like a Pepsi can or a 7-Up can or something. These cans are made of aluminium anyway. They're not made of iron. So we don't do galvanizing for a drink can. Okay, state 2 other methods used to prevent iron from rusting. So instead of galvanizing, name any other 2. So we could say painting, oiling, covering with plastic, sacrificial protection, any of the other methods. Some students investigated displacement reactions involving 3 different metals in solutions of their salts. This equation represents one of these reactions. So this is a reaction between zinc and copper sulfate. This reaction occurs because zinc is more reactive than copper. We said if zinc is more reactive than copper, then it displaces it and the copper metal is formed. When a displacement reaction occurs, there is a temperature rise. The bigger the difference in reactivity between the 2 metals, the bigger the temperature rise. What word is used to describe reactions in which there is a temperature rise? Do you remember that from previous? When a reaction heats up, we call that exothermic. It gives out heat, its temperature rises, it is exothermic. The students use this method. Pour some metal salt solution to a beaker, place a thermometer, record the temperature, add some of the metal and stir the mixture, So what he's doing is, he has the salt solution in a beaker, he measures its initial temperature, and then when he puts the metal and stirs, he measures the maximum temperature. State 2 variables that the students should keep the same to ensure that the experiment was valid. We said when we're trying to compare between different types of metals or different types of solutions, what was he doing? He was putting different types of metals. So what should I keep constant? The volume of the solution and the mass of the metal. They are different metals, but I have to use the same mass. You could also say same surface area of metal, same concentration of the solution, same, what else? I think that's it, okay? The diagrams show the thermometer readings at the start and at the end of one of the experiments. So, record the temperatures and calculate the temperature rise in this experiment. These are typical questions, so you should be able to solve them. Temperature at the start, you should read the thermometer. And please read it accurately. Were you able to read it accurately? This is 18.7 because you have 15, 16, 17, 18, and then between them that's 2, so it's 18. 0.2, 4, 6, it's 0.7, between 0.6 and 0.8. Temperature at the end, you should have read it as 26.8. Were you able to read that? Okay. That means the temperature rise is just the difference between them. 26.8 minus 18.7, so that is 8.1. Now each experiment was repeated twice. The table shows the average temperatures obtained. Use these results to identify the more reactive metal in each of the following pairs. Remember that we said, if, for example, I have zinc plus copper sulfate and it gives a temperature rise, that means that zinc is more reactive than copper. If I don't have any temperature rise, then zinc is not more reactive than copper. Do you understand that? Okay. So if he's comparing zinc and X, where is zinc and X? Then I need the equation that says X plus zinc sulfate. Now, X plus zinc sulfate did not give me anything. But zinc plus X sulfate gave 2.7. Can you see that? So you're comparing these two. The one that gives a temperature rise was zinc plus X sulfate. That means which one is more reactive? It is the zinc. When you put X plus zinc sulfate, it didn't react. That means that the X is not more reactive than the zinc. Okay, copper and X. Where are the ones that involve copper and X? We have X plus copper sulfate gave 8.3. Can you see that? And way at the bottom, copper plus X sulfate did not work. Now, copper plus X sulfate did not work. That means that copper is less reactive than X. And X plus copper sulfate, that reacted. That means that the one that is more reactive is X. Okay? Write an equation for the reaction with temperature rise of 2.7. Where is the temperature rise of 2.7? That is the zinc plus X sulfate. So you just write it as it is. Zinc plus X sulfate would give what? Would give zinc sulfate plus X. We don't know what's X, but we don't care. So just why the students did not use calcium in these experiments. Why do you think they did not use calcium? Remember that calcium is too reactive. It's way at the top of the electrochemical series with potassium and sodium and so on. So these would be too violent. The reactions would be too violent or too vigorous. This is because the calcium is too reactive. Okay, another question. When magnesium is burned in air, it reacts with oxygen to form magnesium oxide. A class of students investigated the relationship between the mass of magnesium burned and the mass of magnesium oxide formed. Each student was given a different mass of clean magnesium to heat. The students used the following method. He said he weighed the crucible and lid, and then he placed the magnesium ribbon and weighed them again, and then heat the crucible until the magnesium burns. Lift the lid from time to time until there is no sign of further reaction. Allow the crucible and lid to cool and reweigh. Repeat the heating, cooling, reweighing until consecutive masses are the same. Calculate the mass of magnesium oxide. So basically, he put the magnesium into the crucible and he weighed them, and then he reacted it and kept weighing it until the mass was constant. First of all, why is it necessary to lift the lid from time to time? Again, we said when we're doing this, we lift the lid from time to time to allow more air to enter or to allow more oxygen to enter. Why is it necessary to repeat the heating until 2 consecutive masses? Usually, how do I know if the reaction has finished or not? I will know it if the mass no longer changes. So when I start burning the magnesium, what will happen to the mass? It's forming magnesium oxide, so the mass will increase and increase and increase until all the magnesium has reacted. No more reaction, that means the mass will not increase anymore. So I'm trying to reach what we call constant mass to make sure that all the magnesium has reacted. Show how the mass of magnesium oxide formed can be calculated from the readings. So what did he measure? He measured the mass of crucible and lid and contents after heating, and minus the mass of crucible and lid alone, because he wants you to tell me how do I get the mass of the magnesium oxide. So I take the mass of the crucible and lid and magnesium oxide after heating, and I subtract from that the original mass of crucible and lid, so I will get the mass of the magnesium oxide alone. The results of each experiment are given in the table. Plot the results on the grid and draw a straight line of best fit. Again, when you have the table, I'm going to remind you that the mass of magnesium in grams will go on the x-axis, the mass of magnesium oxide will go on the y-axis, and then we have these and we're plotting them. So one of them is way away from the line. I don't include it. Since he says this is a straight line of best fit, I try to include as many of the points as possible. If one of them is way off, just ignore it. Draw a circle around the anomalous result. Of course, the one that is way off, that's the one that we call an anomalous result. Use your graph to find the mass of magnesium oxide formed when 0.48 grams of magnesium is burned. So I look at the mass of magnesium. Where is 0.48? I go up to the line, go horizontally, so that's at 0.8, then my mass is 0.80 grams. Were you able to get that? Okay, the next question that you had in your PDF questions are 3 questions. There's 3 students decided to investigate the rusting of some iron nails. They measured the mass of each nail before placing it in some water. After rusting had occurred, the nails were removed and their masses were measured. The table shows the results. So just one problem in measuring the mass of a nail after rusting. Remember that we said that rust is flaky. Do you remember what I said about flaky? Flaky means that it peels off easily. So some of it may fall off as I remove the nail and try to weigh it. Some of this flaky substance may peel off and fall off from the nail. Student A thought that the results showed that his nail had rusted more. Where is student A? He started with a nail of 3 grams and he ended up with 3.3 grams. So that's an increase of 0.3. The others increased only less. 1.5 to 1.7 is just an increase of 0.2. And that means that A had more increase in mass. So that is why he thought that his nail had rusted more. But then student B thought that the results showed that her nail had rusted most. Why do you think that student B would say, no, my nail is the one that rusted more? Because student A started with 3 and it increased by 0.3. Student B started with 1.5 and it increased by 0.2. That means there is a higher % increase in mass. So even though her nail in B was smaller, it rusted a lot. So that means it rusted more. How do the results of student C show that he must have made an error in his experiment? Where is student C? He started with 0.8 and he ended up with 1.7 after rusting. And after rusting, the mass decreased. No, after rusting, the mass should increase. So the mass decreased instead of increased. Most methods used to prevent iron objects from rusting use a physical barrier. This involves covering the iron object with another substance to keep out the water. Complete the table by choosing words from the box to suggest the substance that should be used to prevent each named iron object from rusting. So what would I use to prevent an a bicycle chain from rusting? Remember that we said the bicycle chain involves friction between the metals, so I could use either grease or oil. Railway bridge, what should I use for a railway bridge? I can just paint it. That is the easiest thing. Some iron objects are coated with zinc to prevent rusting. The zinc initially acts as a physical barrier, but an extra advantage of using zinc is that it continues to prevent rusting even if the layer of zinc is damaged. State the name of this type of rust prevention. What was the name of that? Covering the iron with a layer of zinc and explain how it works. That was called galvanizing. And galvanizing works because zinc is more reactive than iron, so it loses electrons and becomes oxidized instead of iron. Which physical property is used to distinguish between metals and non-metals? It is possessed by all metals, but only one non-metal. We said all metals do what? They conduct electricity. Non-metals do not, except for what? Except for graphite, which is carbon. Okay, the reactivity of metals can be studied using displacement reactions. In these reactions, one metal is added to a solution of a salt of a different metal. If a displacement reaction occurs, there is temperature rise. A student used the following method in a series of experiments. Pour some metal solution into a polystyrene cup. So what he's doing is he puts the solution in the polystyrene cup, supported in a glass beaker, record the temperature of the solution. So he's recording the initial temperature. Add a known mass of a metal, stir, record the maximum temperature of the mixture. Now, suggest 3 variables that should be kept the same for students' experiments to be a fair test. What he's changing is he's changing the metal. So that's the only thing that should change, the type of metal. So once I could be using zinc or magnesium or whatever. But everything else should be the same. Everything else like what? Like the volume of the solution, the concentration of the solution, the mass of the metal, the surface area of the metal, if you want another one. Okay? The student used a thermometer to measure the temperature rise. The diagrams show the thermometer readings before and after adding the metal. Use the diagrams to complete the table. So temperature after adding the metal, where is after? After is there, that is 22.4. Can you read that? Now before adding, where is before adding? That's 17.7. The temperature change, the difference between them is 4.7. The student used copper sulfate solution in all her experiments. She used 5 different metals. She did not know the identity of metal X. The student did each experiment twice, so she got the average temperature rise. Which of the metals gave the least reliable temperature rise? Where do I have least reliable temperature rise? Remember that if you repeat an experiment twice, your results should be very close to each other, right? But the results, can you see the result with magnesium? The result with magnesium in run 1, it was 10.5. Now she repeated exactly the same experiment and she got it 15.5. So that's a big difference. They should really be close to each other. For the others, for example, for iron, once was 3.5, the other was 4.5. That's relatively close. For zinc, once was 8 and the other was 9. That's very close. But from 10.5 to 15.5, that's a big difference. Okay. Identify the most reactive of the metals used. So let's look at the table again. Which one was the most reactive metal? We said the most reactive metal would be the one that has a higher average temperature rise. So which one had the higher temperature rise? Magnesium. So that is the more reactive metal. Okay. Why is there no temperature rise when silver is added to copper sulfate? We said if there is no temperaturized, that means that it did not react. And if it did not react, that means that the silver is less reactive than copper. If I put silver in copper sulfate, no reaction, that means that silver is less reactive than copper. Why do the results make it impossible to decide which of the metals is the least reactive? Of course, if I look at the table, silver did not react and X did not react. So I cannot tell which one is less reactive than which. So both silver and metal X did not react. Magnesium burns in oxygen to form magnesium oxide. State two observations that can be made when magnesium burns in oxygen. Again, when we burn magnesium in oxygen, we said, what do we see? White ash is formed and magnesium burns with a bright white flame. Give the formula of magnesium oxide. Magnesium oxide, that's Mg and O, and the valency of magnesium is what? Magnesium is in group 2, so I should put 2 under the oxygen, but then the valency of oxygen also is 2, and we said if this is 2 and this is 2, they cancel each other, so I don't write it. A small amount of magnesium oxide is dissolved in water. When universal indicator is added to the solution, the indicator turns blue. What does the observation with the indicator show about magnesium oxide? If I put of course, if I put something in an indicator and the universal indicator turns blue, that means that the solution is alkaline. Identify the ion that is responsible for the universal indicator turning blue. We said the universal indicator will turn blue if something is alkaline, and something is alkaline if it has OH minus. This is OH minus. A student used this apparatus to find the percentage by volume of oxygen in a sample of air. She used this method. Place some wet iron wool in the bottom of a test tube. Invert the test tube in a beaker containing water. Measure the height of the column of air in the test tube. Leave the test tube for 1 week. Measure the new height of the column of air. Remember that if you put iron way at the top of that test tube, the iron will rust because it will be exposed to oxygen from the air in the test tube and water vapor that is present. The table shows her results. Initial column of air is this. Final height of air is this. That means that the water will go up. As the iron rusts, it uses up oxygen from the air, so the water will go up. Some of the iron turned into rust. Write a word equation for this reaction. If iron turns into rust, how do we write this as an equation? We said iron needs what? It needs oxygen and it needs water, and that what is formed is what we call hydrated iron 3 oxide. So that is the word equation. Now use the student's result to calculate the percentage of oxygen in the sample of air. Now of course the iron reacts with the oxygen and the water goes up to replace the oxygen that reacts. So if I had an initial height of 80 and the final height is 63, then the difference between them is actually the amount of oxygen that was used up. Now I want percentage, so I divide this by the total initial height of the air times 100. That gives me 21% of air, which is the normal level of oxygen. Titanium is extracted from its main ore, something called rutile, I don't care, in a 3-stage process. So he says, rutile, please do not be shocked if you see something you've never heard. I don't care what rutile is. He is going to tell me what it is, since I did not study it. So rutile is heated with chlorine and coke at a temperature of about 900, and he gives you the equation. This gives you titanium chloride. Titanium chloride is then added to liquid magnesium at a very high temperature, and then during the reaction the temperature rises to about this. Magnesium chloride is removed by distillation from the mixture formed, leaving behind pure titanium. So in stage 1, can you see the equation for stage 1? Is the carbon oxidized or reduced? Carbon has changed into what? Into CO, which is carbon monoxide. So that is gain of oxygen, that is oxidized. So the carbon was oxidized because it gained oxygen. What does the reaction in stage 2 indicate about the reactivity of magnesium compared to titanium? He has magnesium reacting with titanium chloride and it reacted. And that means that which one is more reactive? Magnesium is more reactive than titanium since it displaces it from its salt. In stage 3, suggest why distillation can be used to remove magnesium chloride from titanium. If I say that distillation is used to remove one of the liquids, in this case, from the other, that means that they have different what? That means that they have different boiling points. Titanium has these properties: corrosion resistant, high melting point, high strength to weight ratio, non-toxic. Complete the table to suggest an important property of titanium for each use. Choose from the 4 properties listed. You may choose a different property for each use, so you cannot repeat anything. So which property do I need to make aircraft engines? Well, I could say corrosion resistant, or high strength, or actually high melting point. But I need to choose something that I'm not going to choose in the others. So I would say high strength to weight ratio, because later on I will need the corrosion resistant one. Remember that he says I can use each one only once. So I will choose that this one is high strength to weight ratio. Replacement hip joints. Do you understand the meaning of replacement hip joints? That means putting something into the body of someone whose hip has, or hip joints has been broken or something. So this involves putting the metal inside the body, and if you put something inside the body, or high melting point, okay, it has to be non-toxic. Now for propellers for boats, the propellers are things that are constantly in water. Here it must be corrosion resistant. Okay. Dilute hydrochloric acid reacts with many metals. A student observes the reaction with dilute hydrochloric acid with 4 different metals, which he calls P, Q, R, and S. She uses the same amount of metal in each case. Use the information in the table to place the 4 metals in order of reactivity. So which of these is most reactive going to least reactive? Most reactive will give more bubbles very quickly. The one that gives more bubbles very quickly, that's most reactive. So which one is most reactive? Were you able to do this arrangement? Q gives many bubbles very quickly. R, many bubbles quickly. S, few bubbles slowly. P, very few bubbles very slowly. So that is the arrangement. Give the names of the 2 products formed when magnesium reacts with hydrochloric acid. Again, when you react magnesium with hydrochloric acid, which products do you expect? Magnesium chloride plus hydrogen. This equation is about the reaction of calcium and some calcium compounds. Calcium reacts with cold water. And we said anything that reacts with cold water will give hydroxide plus hydrogen. So state 2 observations that are made when calcium reacts with water. Again, this is something that gives out a gas, and I'm starting with a solid. So the gas is in form of bubbles of gas, and the solid I started with will dissolve or disappear or become smaller. Any of them is correct. So you can either say solid dissolves, or the solid becomes smaller, or the solid disappears. Explain a possible value for the pH. Remember that he says explain, not suggest. If he says suggest, then you give me just the pH. But if he says explain, that means you give me the pH and tell me why. So explain a possible value for the pH of the solution. Of course, I know that what is formed is calcium hydroxide. Calcium hydroxide is alkaline. Calcium hydroxide is actually a strong base. So the pH should be something around 12. Actually, they will give you any mark for any pH above 7. This is because calcium hydroxide is alkaline or basic. The diagram shows some reactions involving calcium compounds. Identify X and Y and Z. So let's see what he's talking about. Calcium carbonate. He heated it to get X plus carbon dioxide. So what is X? That must be calcium oxide. When you heat a carbonate, it gives calcium oxide plus carbon dioxide. Now, he put the calcium oxide in water. That gives calcium hydroxide. Now, when he added HCl to the calcium hydroxide, he should get what? Calcium chloride. And then, when he added carbon dioxide to the calcium hydroxide, what do you think that should give? That is calcium carbonate. Okay, the apparatus in the diagram was set up to demonstrate the rusting of iron. 1 week after the start of the experiment, the volume of gas in the measuring cylinder has decreased. Remember that we said if you put iron wool at the top, the water rises to replace the oxygen that is used up in rusting. So after 2 weeks, there is no further decrease in volume of gas in the measuring cylinder, and you're supposed to explain all of these. Why did the water rise after 1 week? And then why did the water did not change after 2 weeks? Of course, we said in the first week, the iron is reacting with the oxygen in the air. So iron reacted with oxygen in the air, so the volume of gas in the measuring cylinder decreased, and the water went up to replace the oxygen that was used. Now, after 2 weeks, obviously, if the water did not change anymore, that means that all the oxygen in the air has already been used up, so no more reaction, and the volume of the gas remains the same. Iron reacts with dilute sulfuric acid. The chemical equation for this reaction is this. Complete the word equation. So you're just writing the names of what is formed. So what is formed is what? Iron sulfate. How did I know it was iron 2 and not iron 3? Remember that when we write iron, we need to identify, is it iron 2 or iron 3? Because we have these two common forms of iron. Okay, so iron, we did not write anything under the sulfate. The sulfate has a valency of what? The sulfate, you should know, has a valency of 2. So actually, I should have put 2 under the Fe. But I didn't put 2 under the Fe because the iron also has a valency of 2. And we said if I have 2 here and 2 here, I cancel. And that is what tells me that the valency of the iron is 2. That it is the same as sulfate. Plus hydrogen gas. Okay, so these were the questions on metals. Please study hard and send me an email and I'll send you the quiz on this chapter. Okay.